Hi, good morning, everyone. Thanks for joining our webinar today. We've had a lot of interest recently from BI, data scientists, and analysts asking us about solutions to connect Power BI to elastic databases, especially like JSON files, non-relational tables. And so we picked one use case that we thought was really interesting, and we're going to go share it with you guys this morning and explain how Conduit is able to bridge some of those gaps. So, and today I have with me Conduit, our Director of Product Development, to do a demo of what it looks like in real life. And so what I'll do first is share a little bit of introduction information, and then we'll move on to what the scenario is actually like. So we pulled a couple of just random pieces of information related to JSON. On the left, you'll see there's a chart that shows the volume of JSON-related questions that's come through Stack Overflow. And you can see it's increased significantly over the last several years. And then we just took, there's many tweets along these lines, but folks who have expressed frustration through social media about writing queries in JSON, doing aggregations, turning that non-relational data into schema tables. So it's the fact that we've recently received some requests, probably not necessarily a unique thing. And so just to tee up and give some background on the scenario that we'll talk about today, this was a company that was doing analytics and data science for one of the largest automotive companies in the world. And what they had done, I'll share just a little bit about their data sourcing. So they've got marketing campaigns stored in Mongo, Cassandra, Cosmos in your non-relational data sources. They had their dealership hierarchy and sales transactions stored in MariaDB and Postgres. So what they did was they took all of it and created a replication analytics layer in Elasticsearch and just dumped it all into JSON because Elasticsearch just indexed all of it. They wanted eventually to run reporting out of Power BI and connect Power BI to that Elastic database. And as I'm sure many of you guys know, Power BI does not connect to Elastic. And so they came to us asking for a solution, and we were able to deliver. So that's the overarching backdrop. And I'm going to turn it over to Conduit, and he's going to explain how that worked.
Cool, awesome. Thank you, Bobby. So just a little more on this use case. They picked Elastic because it's a highly scalable distributed system. They wanted to store all this data, merge from all these sources, NoSQL and SQL sources into JSON. It's the easiest thing to do, right? For engineers, developers, they're building data pipelines to just merge all that data into this one readable format. And they basically stored JSON fields in Elastic documents. So now, not only they wanted to connect Power BI to Elastic and read this data, which is not possible today. There's no native connector in Power BI for Elasticsearch. They also wanted to be able to query that nested JSON data. There is 5-6 level of nesting in that JSON output that they created, and they really wanted to aggregate at the 5th or 6th level in that JSON, which can be very expensive. So we provided Conduit, allows them to connect to Elastic. By the way, the Elasticsearch is in AWS, so it's a managed AWS Elasticsearch service, which has security. And they wanted to aggregate at a 5th level, and not only aggregate natively, but also do something like count as string. So they wanted to support non-native aggregations in Elasticsearch. So the problem was really complex challenge and challenging, and we were really happy to just help them out. So I'll show how that looks like now in the demo. So I'll turn over to one deployment of Conduit we have. I'll show you what we have in Elastic. Basically, in AWS, we have this Elasticsearch service with security turned on, just to basically simulate their environment. There's 2 nodes in that Elastic cluster, 400 gigabyte storage for each, SSD, pretty much classic AWS Elastic deployment. There's a few indices that I'm going to be demoing. This one is a 1 million document index we have in the demo, and then a smaller one of 100K. I'll show you how the data looks like. It's not obviously the customer data. We're not going to share that, but we'll have something similar that has a lot of multiple levels of nesting. So I'll show you our 1 million index here, and you can see the JSON structure here in so many levels of nesting, and they really wanted to do a count distinct on something like a medical code, right? And the challenge is, yes, Elastic supports native JSON queries, and you can query this particular node natively in Elastic. You can do a count, but you cannot do a count distinct, right? As soon as you do count distinct, which is what the customer wanted, Elastic doesn't help you anymore. So at that point, you have to bring an external compute engine like Spark that has to go in, read all the data, explode all the JSON into a format where you can actually aggregate on this deeply nested field, and that's what Conduit does. So I'll show you what the experience is with Conduit. You have to create an Elastic connector. We'll connect to this data source. Now we'll provide a URL. Then we'll provide the authentication. What's important that Conduit has to connect with an access key. That's your AWS security. But on the front end, Conduit allows you to do anything like Active Directory or internal authentication. You can connect with your AD credentials into an Elasticsearch. It doesn't support that at all, right? So that's another feature that Conduit allows you to leverage. Then we publish that index. And when we do that, since we're taking a deeply nested structure into Power BI, Power BI can only display tabular form, right? A relational like form with flat tables, rows, and columns, right? So in order for us to allow it to query on a deeply nested field, we had to flatten out that schema initially, right? So that's how you see all these fields are now employees, board, benefits, medical coverage, right? And then all the fields in that nested structure are flattened out, so we can now present this as a list of fields in Power BI, right? And that's what the user will see, and they'll be able to pick this, for example, employees, marketing, research, benefits, medical code, and do a count distinct on that. They can also unselect basically fields here if they wanted to reduce the payload, help us performance, because this will be a very expensive operation to explode an index like that to allow Spark to actually query. We also enable caching, so we don't have waste the time of loading the documents from Elastic and actually show the queries. We're going to skip the authorization. What we said is we want to cache this for let's see, the 1 minute document. We want to cache that according to a policy, and then specify some parameters for how to ingest that from Elastic, the partition size, the fetch size. Those are parameters that allow us to fine tune and provide the best performance. And in the end, you're presented with the endpoint. So what Conduit does allows you to now take this endpoint, the Power BI Spark connector, and go to Power BI and query this Elastic service. So the way you do that, let's go to Power BI. I have this on a VM. What you do, you go to retrieve your data, and Conduit for Power BI or Tableau or any other BI tools is a Spark connector, right? So we impersonate Spark here. We have the same interface, the same JDBC endpoints and as Spark, and paste that in. Let me see if I can paste that in over Windows. Because this is a Windows VM, and I guess it might not let me Let's see if you can let me, yeah, that should work. Paste. Not have to type it. Okay, cool, worked. So we're providing the Conduit URL, right, which will allow you access, to give you access to all of the data sources managed by Conduit. We picked the HTTP protocol. It's all about direct query. You know, we wanted to do this real time. That's another requirement from the customer. They wanted to query that Elastic in real time and not import data into Power BI. So now Conduit will show all the assets that I have access to. We'll pick. Now I've already loaded this data set, but you can look at the preview of this 1 million market, right? Demo market index. That's how it looks like. You see that the preview already shows you the flattened out structure, right? We took that nested JSON and we show them basically this flattened out tabular format, right? So we loaded that into Power BI, and my index is here pretty much. Everything is flattened out. So now I can go in and pick my code, employees benefits, for example, medical code, and I can do a count distinct on it. And so the initial query is a table. Let's turn this into a bar chart, like this. And then let's take this on the value box. And this is now a count. And this goes natively against Elasticsearch. That's where you see 941,000 records. But as soon as I do count distinct, that's going to employ Spark. And you should see a smaller number because they're duplicates. And that's your 51, basically codes, right? So now that's your experience in Power BI. That's all you have to do. You're working with this deeply nested index with JSON fields in Elastic from your Power BI as if you were talking to a local data set or a SQL Server database, right? That's what Conduit did. Abstracted this NoSQL database into a easy to query, flattened out data set. How much time do we have left?
Just a few minutes. So that's essentially the solution that we worked out. If you have any questions, feel free to ask. You can either ask in the chat, and we'll give you guys a couple of minutes to ask these questions on here.
Yeah, and then there are no questions. I'll continue to show the queries and everything that we ran behind. What Conduit did basically behind the scene, and I'm sure people that watch this webinar later will be interested now. We're not going to share the secret sauce, but we want to show some of the magic that we did behind, because it's very complex work, right? So I'll go to our Conduit will also give you an Elastic ELK dashboard here with all the logs, so you can go ahead and query and see exactly what happened behind the scene. And I'll look at the last query, and I'll check the correlation ID on that, and that will give me the entire stack of the call, right? From Power BI. Now I will sort here descending, and I will see what happened behind the scene. And you'll see that we received this query from Power BI, right? Power BI emits a select statement, right? Because this is a flattened out structure. You see it's looking for the medical code here as a field. What we did is, because we figured out this is a count distinct, we turned that into a Spark over Elasticsearch query. And in the end, we did all this work, and then we retrieved the results, and we converted them back to Power BI in a tabular format. I also wanted to show you that if we also had the initial count query that was native query, right? That didn't require Spark. Whenever Conduit can translate a query to the native format of the data source, it will do that, because now we feel like the data source is best equipped to handle those type of queries. So I'll look at the let me run another query from Power BI just to see it, a native one. So I'll go back to let's see another one. Let's do another bar chart, and let's pick coverage this time. I'll drop it in a value field. This is a sum, so this should execute natively. Let's see what we have as a query behind. refresh here. Okay, I'll take the last. I'll take the last query. Correlation ID, filter on that. So that giving me all the log entries for that particular query, and then we should see the query here somewhere in this list. Okay, so I picked the wrong. Is this a wrong correlation ID? Okay. Yeah, just one more thing I want to show you. Okay, there we go. So this is the native query that we run against Elastic, right? This is the query. This is classic, JSON type query against Elasticsearch. The sum, the aggregations on that employee coverage field. So this is not for anybody to write. So people are more familiar with SQL and select statements, and they understand that easier than this semi-cryptic JSON syntax that Elastic requires. So that's what Conduit does behind the scene. Now, either translates to Elastic natively, or it's going to employ Spark for operations like aggregations that are not supported, like account listing. And that's pretty much what I wanted to demonstrate.
Cool. There are no questions. Thank you for your time. And if you are interested in learning more about data connectivity and data virtualization, feel free to reach out. Thank you.